want to test if people, irrespective of the education level and the same income, we can use the one-way analysis of variance or one-way ANOVA. And the null hypothesis will be that all the mu's are the same, meaning that all the groups that you have, they have the same mean, and then the alternative is at least one of the mu's is different. And we want to find out through an example how we can do that. So I'm going to create a simple hypothetical data, and one of the things is I'll look at education levels, which in this case I'll look at let me say I'll look at 3 education levels. You have a primary, secondary, or tertiary. The first one is primary, the second one is secondary, and the third one is tertiary education level. And let me call them ED, ED dot L, okay, ED dot level. And I'm going to create some 8 or 10 values. Let me assume the first two people are from primary, that one is secondary, the fourth one is tertiary, the fifth one is secondary, the sixth one is secondary, the seventh one is tertiary, the eighth one is secondary. Those are 8, and maybe I can put another primary level of education, 9, and then maybe I could also put the 10th one as tertiary. That gives me my education level, and I can find out what class this data is. I can get the class of ED level, and I see it says oh sorry, the first thing is then we do the build, and then I come down and check the class, and it says it's a character. So I want this to be factors because I need 3 factors for me to be able to use the analysis of variance test the one way. So if I have that, now if I test again, I can see now I have them as factors, which is what I needed. The next thing I need is income of the 10 people. So I'll call it income, and I can have values, let's say in dollars. One is 1,000, another one with primary is 1,300, secondary is 1,400, tertiary is 2,100, secondary is 1,800, another secondary is 1,600, another tertiary is 2,200, another secondary is 1,500, primary is 1,500, and secondary is 1,700. Those are 10 values that I have, and if I check them out, I realize that I have the number that I need. So now what I want to do next is I want to combine these two sets of data. I want to create a data frame for income and education level. So I'll just call it a DF, standing for data frame, and I say as a data dot frame. Then I'll bind them. I'll column bind them so that I have 2 columns of data, and one of them is income, the other one is ED level. That's what I have, and I also check if my file is okay. You can do so many things. You can decide to view your data frame. If I come down here and say view DF, and off it takes me, that is how my data frame will look like. Back to what I was looking at is now I want to introduce my ANOVA. What I forgot is I've not used these files today, so maybe it's good to load them afresh so that there's no package. That's unusual for me to find that there is no package called LM, because I expect to use it anyway. Let me emphasize on that. If it says there is no package, then I can say install.packages. Let me see if there is a package called LM, and if there is, then I should be able to use it. It is installing. I don't know why it is claiming there's no package. I've used it before, but as it does, there's no LM found for that. Let's see if it will still work. So what we want to do is we want to get the computations. We get the one-way ANOVA, and I can call it ANOVA 1 underscore way. And what I'm going to do is I'm going to use the AOV package. So I'll say it's income that is determined by the indication level, and remember the indication levels were factors that we had, and I say my data is df. Let's see what we get. It works. So if I want to see what I have, I can just get a summary of ANOVA underscore one way, and that gives us some very nice figures. There is a p-value here which is 0.7%, which is highly significant, telling us that the mu's are different. So depending with the education level, your income will change. That's basically what we are saying. Now, how do you know which one was better? From our data, what we do is we undertake what we call a post-hoc test. And a post-hoc test will help us to give us the difference between all the three categories, how they differ. So we use the Turkey HSD test. I get the AOV of income to education level. Was it education level? ED level? Yes, that was the case. And then I can also give my confidence interval. Confidence level is equal to 0.95. That's basically it. So let's find out. If I come and type here post hoc, what are we finding? We are finding that between secondary and primary, the difference in income is, the mean difference is 333. Tertiary and primary is 883, and tertiary and secondary is 550. So the difference, the mean difference between tertiary and secondary of 550 is statistically significant with a p-value of 2.05%. Tertiary and primary, the mean difference is 883, and also the p-value is 0.27%, which is also statistically significant. But the mean difference in income between secondary and primary is 333, and it shows that it is not statistically significant. The LWR and UPR is the lower and the upper confidence intervals for your analysis. When you look at the first case, you find that the value 0 lies between -57 and +724. That's why there was no statistical significance there. So that's the purpose of the post-hoc, to help you to see where the difference was. Something else that we could do is also we can calculate the group mean of these groups, the three groups that we have: primary, secondary, and tertiary. Then we have the group mean. So we say T apply. We want to apply for the table. We have the income, we have the education level, and then what we want to get is the mean of that. So if we do that, we find that the group mean, if you wish, you can say group underscore mean here. You can put it there, and when you click that, it tells you that the primary mean was 1266.7, the secondary mean was 1600, and the tertiary mean was 2150, giving you the different mean values in the income depending with your level of education. Please remember, this is just an example that we have used to help us to see how we can use one-way ANOVA. So for you to be able to use one-way ANOVA, you need to have the dependent variable, which is continuous, like income, and then you have to have 3 or more factors for you to be able to. So your data should be able to be grouped into 3 groups or categories, and this is what we refer to as factors. So in conclusion, the income depends on education level with those having tertiary level of education earning more than the other two groups. And I hope you've enjoyed and it was clear to you. And in case you have any questions, you can always let me know.